Hello, everybody. Today we are going to be talking about the volume of cylinders. Now, we set up volume a little bit yesterday with our in-class activity, but there we were talking about the volume of a prism. The volume of a prism, or as you guys may call it, a box, is something you should have done in a previous grade. So today we're going to talk about the volume of a cylinder. Okay, and again, volume is going to be the measure of the space occupied by a solid, or how much space something takes up. That's what we're talking about when we talk about volume. Okay, and a cylinder, by the book definition, is a three-dimensional figure with two parallel congruent circular bases connected by a curved surface. Okay, so a cylinder would be a trash can, or maybe an oil barrel. A pop can are good examples of cylinders that you might have seen in your life. Okay, so really, when we talk about our volume of our cylinder, okay, we take the area of the base, which is capital B, times the height. Okay, now since our base, or our end shape, is a circle, the capital B, or the area of the base, is equal to pi r squared, because that is the area of a circle, where pi is obviously pi and r is the radius of that circle. If you remember, a diameter goes all the way across a circle. The radius only goes halfway, or from center to rim. Okay, so that's the radius. So you're going to take pi times the radius squared times the height, and that will be the volume of our cylinder. Okay, so really what we're doing is we're taking the area of one of these bases down here, and we're just multiplying it by how many of those we have. Kind of like yesterday when we talked about one layer of money multiplied by the number of layers. Okay, same concept here. So it says find the volume of the cylinder, round to the nearest tenth. So volume is equal to pi r squared h. Okay, if I look over here, I see that my radius, or r, is 5, and my height is 8.3. So all I need to do is plug that in and multiply. Okay. This is an easy one. 5 squared is 25, so I'm going to simplify just a little bit. And from here, I'm just going to use my calculator. And I need to change my batteries. So I just take pi times 25 times 8.3, and that's going to be 651.88. Now it said round to the nearest tenth, so the tenth is only one decimal place. So I look here, is that 5 or larger? Yes, it is. So this becomes a rounded answer of about 651.9 centimeters cubed. And again, we're going to use that cubic centimeter because volume is the measure of space. Okay, volume is a measure of space something takes up in 3 dimensions. If we think about our units of measure, okay, if we are in 1 dimension, or 1D, okay, that's just the length of a line. Okay, so this would be centimeters. Okay, that would be how we measure length. If we are in 2 dimensions, length and width, length times width, that would be centimeters squared, and that would be area. But what we're working in 3 dimensions, 3D, so we have centimeters cubed, and that is volume. Okay, so remember, when we find volume, we are using cubic units. Okay, cubic units. If we take a look at example number 2, it's exactly the same, except now instead of having a diagram, it just tells us in words. So it says find the volume of a cylinder with a diameter of 16 inches and a height of 20 inches round to the nearest tenth. So again, I start with my formula, V equals pi r squared h. Now, the tricky part here is it gives us a diameter. Okay, but we remember that a diameter is twice the radius. Okay, so if our diameter is 16, okay, our radius would be 8. So r is equal to 8, okay, inches. And then it says a height of 20, so h equals 20. Again, all I need to do is plug it in. V equals pi times 8 squared times 20. Again, just to make it a little bit easier into my calculator, I'm going to evaluate this perfect square. 8 squared is 64. Okay, and I'm just going to type that thing in exactly the way that I see it. Pi times 64 times 20. Okay, and we get V to equal 4,021.23, and again it says round to the nearest tenth, so that becomes V to equal 4,021.2 inches cubed. So again, really these first two examples, all we got to do is plug in the information and simplify. Go ahead and try A and B on your own. I'll be back in a minute to go through those with you. Alright, should be back from trying A and B. Let's go through them. Go through them fairly quickly. V equals pi r squared h. R is equal to 3. H is equal to 1.8. Plug them in. 3 squared is, let's see, pi times 9 times 1.8. Type it in on my calculator. And I get V to equal, and again, round to the nearest tenth, so we'll go 50.9 inches cubed. That would be the volume. Okay, 50.9 inches cubed. The next one, B, again, this is a diameter, so we need to cut it in half to find my radius. So V equals pi r squared h. Pi times 6 squared times 5. Pi times 36 times 5. That should be 565.5 millimeters cubed. And those should be your two answers. So really just a lot of number crunching. One thing we've really got to make sure we put the correct numbers in the correct spot. Be sure to watch out for a diameter. Make sure you cut it in half to find your radius. And then from there, all we got to do is put it in the right spot and calculate the numbers correctly. Okay. Take a look at number 3. Example number 3, a metal paperweight is in the shape of a cylinder. The paperweight has a height of 1.5 inches and a diameter of 2 inches. How much does the paperweight weigh if 1, and I know it says square inch. This is going to be cubic. Cubic inch weighs 1.8 ounces, round to the nearest tenth. So basically what we need to do is find the weight here. And in order to do that, we need to find the volume first. Okay, so V is equal to pi r squared h, where h equals 1.5. Now again, diameter, cut it in half, so my radius would just be 1. So V is equal to pi times 1 squared times 1.5. 1 squared, of course, is 1. Type it in. And we get our volume to be 4, and I'm going to carry this one out because we're not done. 4.7123. Okay, so that's my volume, but it doesn't ask for the volume. It asks how much it weighs. Okay, so if 1 cubic inch weighs 1.8 ounces, how much would this weigh? Well, we multiply this by the 1.8 ounces, and that'll tell us how much it weighs, because that's how much space it takes out. So again, I'm going to leave it in my calculator and multiply by 1.8 because that's going to give me the most accurate answer. So from here, I'll round to the nearest tenth, and I'll get 8.5 ounces. 8.5 ounces. Make sure you read the problem carefully. If it's asking for a weight, give the weight. I know we need to find the volume in order to find the answer, but if you were to just give the volume and not finish the problem, you're definitely going to lose points. Okay. At this point, you should be able to stop and try question C on the Got It section on your own. So go ahead and pause and try this one on your own, please. All right, we should be back from trying this one on our own. Again, it's essentially the exact same thing, except for the average. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per square foot. And again, I'm going to say this would be per cubic foot. Per cubic foot. Okay? So we start with our volume equals pi r squared h. Our radius, again, we need to cut this diameter in half, so 1.5 divided by 2 should be 0.75. So that's going to be our radius. And our height, I don't know if you guys can see this, your height is 4 feet. So when I plug it in, v equals pi times 0.75 squared times 4. Now this one, I don't know what 0.75 squared is off the top of my head, so I'm going to type the whole thing in there. Pi times, now make sure, I always put it in parentheses just to make sure, 0.75 squared times 4. And I get 7.06858 dot dot dot. And again, I carry that out so I don't have to round until the very end. So that's how many, let's see, cubic feet that our container would be. So now we want to know how much that would weigh. If on average it weighs 37 ounces per cubic foot, we multiply by 37. And again, I'm just going to leave it in my calculator and go times 37. And I get an answer of 261.5 ounces. So again, make sure on this type of problem you read the problem, you understand what they're asking for, and then give that to them. Okay. Now the second part today, we're going to talk about something called a composite solid. A composite solid is made up of more than one shape. Okay. So if we take a look at example number 4 here, it says Tanya uses cube-shaped beads to make jewelry. Each bead has a circular hole through the middle. Find the volume of each bead. So what we want to do is take the volume of the cube and subtract the volume of the hole. And if you look at the hole is essentially a cylinder. Okay, so volume of a cube, we take the length times the width times the height. And we're going to subtract that from the volume of our cube, which is pi r squared h. So in terms of the volume of the cube, length times width times height, it's 12 times 12 times, and I wonder if I'm missing a dimension here. Well, it's a cube, right? So all the sides are the same, 12 by 12 by 12. Okay, so 12 by 12 by 12. Okay, over here, this is all the way across. If you can look at that, 2 millimeters is all the way across that hole. So our radius would be 1 millimeter, and our height would be 12. So on this side, I take 12 times 12 times 12, and I get 1728. Here, I can take pi times 1 squared times 12, and I get 37.6991, and I'll stop there. So then I just subtract the two, 1728 minus, and if you put this answer in here, second answer, you're going to get the most accurate answer. But really it comes out pretty even anyway. Okay, so I end up at 1690.3. Okay, and we're in millimeters, so that would be millimeters cubed. So again, these ones are a little bit trickier. You have to address each one individually and look at what you're doing. Since this is a whole, we're taking that away, so that's why we subtracted. Okay, take a look at D. See if you can figure out D on your own. Okay, see if you can figure out D on your own. All right, you should be back from trying D. This one's a bit tricky. We are going to add. We're going to take the volume of our prism, or the box on the bottom, and we're going to add half the volume of a cylinder, because that's half a cylinder. Okay, so the volume of a prism, length times width times height, plus 1/2 times the volume of our cylinder, pi r squared h. length times width times height is 30 times 25 times 50 plus 1/2 times pi. Now the radius here, this distance here is the same as this distance here, so that's 25 all the way across, but that's a diameter, so half of that is going to be 12.5. So I take 12.5 squared times, and then the height is going to be this distance here, which would be 50. On the right-hand side, sorry, left-hand side, I take 30 times 25 times 50, and I get 37,500. Over here I have 1/2 times pi times 12.5 squared times 50. I get 24,543.69. And I cut that in half. Oops. So I have 37,500 plus 12,271.8463. I add those together, and I get my final volume of 49,771.8. And we're in centimeters, so this would be cubic centimeters. So again, each one of these composite solids is kind of their own thing. You need to be able to evaluate what you need to do. The tricky part on this one was understanding and seeing that this was half of a cylinder. Okay, half of a cylinder. Alrighty, that does it for this lesson. Here is the assignment, red, yellow, green. The choice is yours. Choose the assignment that best fits you. And as always, have a great day.